Welcome to Comfort Learn classes. In this series of videos, I will solve previous year questions, NCERT important questions, and few questions from the sample papers from the chapter Continuity and Differentiability from PU second year. If you have any specific questions to be solved, either from some reference or from NCERT, you can just put it in the comment section. Let's start with the first question. Is the function defined by f of x is equal to x if x is less than or equal to 1, phi if x is greater than 1, continuous at x is equal to 0, 1 and then 2. Fine. So now here the given function f of x will have two different values for two different inputs. We have two different ranges here, input values, that is x is less than or equal to 1 and x is greater than 1. And we need to check the continuity of the function at three different points: x is equal to 0, x is equal to 1 and x is equal to 2. So let me start with x is equal to 0. Before that, let me draw the input values. So here at this point the function is changing, that is at x is equal to 1. So if x is greater than or smaller than 1, smaller than or equal to 1, if x is smaller than or equal to 1, that is including 1, the value of the function is x. Okay, on the other side, if x is greater than 1, the value of the function is phi. So now the first point at x is equal to 0. So x is equal to 0 we have somewhere here. Now we need to check the continuity of the function. And what is the value of the function here? F of x is equal to x. And we know that if the function is a polynomial function, then it is a continuous function. And here at x is equal to 0, right, at this point, either you approach it from left hand side or right hand side, the value of the function will remain same. Or you can just see graphically, if you see the graphical representation of this, you will find a straight line, right? What is the f of x is equal to x? It is an identity function, so it will be somewhat similar to this, right? So at x is equal to 0, it is a continuous curve, so hence f of x is equal to x is a continuous at x is equal to 0. Or you can just write as f of x is equal to x is a polynomial, f of x is continuous. F of x is continuous at x is equal to 0. And let me take x is equal to 2, then we can go for x is equal to 1. So now at x is equal to 2, the value of the function f of x, we have 2 here, and the value of the function is phi. At x is equal to 2, the value of the function f of x is equal to pi. Again, either it is LHL or RHL, the value of the function is same, right? It is a constant function. Just write as f of x is a constant, as f of x is a constant, it is continuous. Okay, so now let me check for x is equal to 1. At x is equal to 1. So now at x is equal to 1, the value of the function is changing here, right? So it is not continuous, similar to 0 and then 2, right? So now in such cases, you need to check for LHL, RHL and then f of x. If all these three are same, then the function is continuous. And let me start with f of x. What is f of x? That is at x is equal to 1, f of 1 is equal to x, or you can just write it as 1, right? And then what is LHL? LHL is left hand limit, that is limit x tends to 1 minus. Okay, when it is left hand, you need to take a minus because we are approaching 1 from left hand side, right? 1 minus and then x. So now 1 minus, that is less than 1. What is 1 minus? Less than 1. If x is less than 1, the value of the function is limit x tends to 1 minus the value of the function for less than 1 x here. Now if you make a substitution, we got 1 for the LHL. So now what is the RHL here? RHL again same limit x tends to 1 plus, okay, approaching from right hand side or greater than 1. So then if x is greater than 1, limit x tends to 1 plus. If x is greater than 1, the value of the function is 5, right? And it is a constant, you will get 5 here. So here LHL is not equal to RHL. If LHL is not equal to RHL, then the function is not continuous at x is equal to 1. You can just write the function is not continuous at x is equal to 1. Okay, fine. Find all points of discontinuity of the function f. So what is f here? F of x is equal to 2x plus 3 if x is less than or equal to 2 here. Okay, so 2 if it is less than or equal to 2, that is including 2, the value of the function is 2x plus 3. Okay, on the other hand, if it is greater than 2, the value of the function is 2x minus 3, right? So now let's check for the continuity of the function. So here first you need to take the ranges or the regions, right? So this is my first region. What is the first region? Less than 2 for x less than 2. For x less than 2, what is the value of the function? F of x is equal to 2x plus 3. And what is 2x plus 3? It is a polynomial expression. If f of x is a polynomial expression, then it is always continuous. So you can just write as f of x is a polynomial. It is continuous. It is continuous for the range x is smaller than 2. So now take the second range or the second region, that is for x greater than 2. For x greater than 2, what is the value of the function? 2x minus 3. Again 2x minus 3 is a polynomial. So you write the same here as f of x is a polynomial, it is continuous. So next, now we got two different regions, right? So that is one here and then one here. Now we need to check the continuity of the function at x is equal to 2. At x is equal to 2. Just remember the flow of the solution. First for the region and then specific points, right? So here let me take x is equal to 2, which is given here, right? Because at x is equal to 2, the function is changing. So now if you want to prove the function is continuous at a specific point, you need to show that LHL, RHL and then f of x, all the three are same. So let me start from f of x. What is f of x? F of 2. And what is f of 2? At x is equal to 2, the value of the function is 2x plus 3. And if you make a substitution, 2 into 2 plus 3. So we get 7 here. So next, let me take LHL. What is LHL? Limit x tends to, that is approaching from the left hand side. If you are approaching 2 from the left hand side, we take it as x tends to 2 minus. X tends to 2 minus or x less than 2. If x is less than 2, then the value of the function is 2x plus 3. Now you make the same substitution, 2 into 2 plus 3, which is equal to 7 again. Now let me check for RHL. So what is RHL here? Limit x tends to RHL approaching it from the right hand side. So your x is greater than 2. Approaching from right hand side, you need to take it as greater than 2. So now if it is greater than 2, the value of the function is 2x minus 3, right? So 2 into 2 minus 3. So which is equal to 4 minus 3, that is 1. So now you can see it here, LHL is not equal to RHL. If LHL and RHL are not same, f is, the function is not continuous at x is equal to 2. Okay, it is not continuous at x is equal to 2, but it is continuous in this region and then in this region. Okay, so now what is the point of discontinuity? That is x is equal to 2.